Okay, what we have here is the input board from a Midas console. This is a 48 channel version of the console. This is a mic input board. You have your gain on this board, your 48 volt phantom, and your pad switch, along with your graphic EQ for your lows, mids, and highs. This particular card has this is channels this is channel 9. Channels 8 and 9 are actually out on the mixer, but this card here is the second card in the system, and someone has attempted to do a repair here. They have put a through hole component in place of a surface mount part, shrink wrapped it and put some tape around it, which is a resistor. Upon closer examination, have found that there is a op-amp circuit here, which this op-amp is responsible for your master gain. Your input comes in through this op-amp. There are some support components, couple transistors here, a couple transistors here. These look like transistor packages, but they're actually looks like Zener diode packages. The two surface mount resistors, one is actually broken off here. They had a through hole component, an additional one taped around to the front, which actually was broken off upon removal of this card. This one here I noticed had been warm, and why they did not put the surface mount resistor back. This is upon examining the other positions here. They are 10 ohm surface mount resistors, which we will be going back with the resistors. Someone has also replaced this capacitor here as well, which is on one leg of the B plus going to this op amp, and as you can see it here, they have put it on its side. It is 100 microfarad at 25 volts. Not sure if there was an overvoltage condition, or maybe the cap just failed. Channel may have been spiked by a power surge, lightning input to the channel. Not real sure what happened there, is why the failure is. Don't have a schematic on these, but this should be pretty well straightforward. Put the meter here on diode check. Kind of look around here. I had kind of started here with some of your front end components here, kind of looking for junctions or shorts. Not knowing, with the schematic here, so I would just kind of try to find junctions. And it appears that, we're not seeing any shorts. Kind of taking that as a junction to junction there, not knowing the characteristics of the two transistors here, but this one's, both of these are checking alike. And we can go over here to the functioning channel and kind of compare. And I'm kind of getting the same junctions compared to the working channel here and the non-functioning channel. Move over here and kind of check this. It's kind of checking like a diode. This pin here appears to be in no connection, and we have a junction. And on the second device we have a junction. This pin, no connection. We'll reverse our leads. We're checking it kind of like a diode. No connection, no connection. And we go over here to the functioning channel. No connection, no connection, no connection to that pin there. Reverse our leads. And notice junction and junction. So we pretty much kind of rule out that those look like they're okay. So here we'll go right here, we'll check a junction, and we'll kind of compare it here to the working channel, junction, and junction. The only question I had was, I believe this transistor here, we're at a rather low amount right there. Like there's a resistance there. We have a junction and a junction there. So this appears to be the base here. So if I check this to the other channel, junction, which checks fine, but then if I go here, I notice that I don't have any kind of resistance there, but here I do. So tracing this pin back, I had found that this pin, these actually go back to right here to the op amp. They're tied, and this leg here I believe is also tied to the supply right of the op amp. So we're going to need to lift this op amp. We know its resistors are going to the ground, and the positive supply going to, it's like a fusible device, 10 ohm resistors. So if anything happens to the op amp, we're going to immediately burn open one or both resistors. We're hoping that this transistor is okay. In that case, we'll just lift this op amp. Pretty sure that op amp is probably shorted, so it being a surface mount device, we'll go ahead here and lift. We'll insert us a small piece of wire through here to help removal of this op amp, and we'll just take our solder wick and we'll kind of remove the unused portion here of the solder wick here that's been old. Just take us some fresh solder wick. Start out with a clean tip, and we will supply some heat. Kind of wick up some solder here. Get a hold of our lead wire here as we're kind of working it underneath the op amp. And that side should be clear. And we will go ahead here and insert our wire back underneath this op amp. And probably a little hard to see on camera because of this small nature of the components. And we will just kind of run that wire through. I'll try to get a little zoom in here, see if I can get you a better, kind of a little better shot of what we're actually doing here. And we'll take our solder wick once again here, and we will kind of apply some heat to the other side of the device. We'll grab a hold of the other end of the wire here, and we just pull it underneath, and we'll have to reposition our wire. I usually tried there to use that wire over again. It usually breaks, so it's best just go ahead and just use a fresh wire out of the stranded wire. Because normally every time I'm reusing one, it gets brittle and breaks, so we'll just run a new strand underneath here. And we will apply our heat once again with our wick. And so we will start slowly pulling our wire out from under the pins. Okay, and we have cleared all the pins. So now, knowing that we should be all free, we will pop our op amp up off of circuit here, and there we have our op amp removed from our circuit. And usually there is like a little dot of glue underneath the trace. So now we will proceed here again. I'll zoom out here so you can see the meter here once again. And what we want to do here is test this transistor once again. And it appears that our low impedance that we're seeing across those two pins are gone, so that means our transistor is checking just fine. Junction is checking just like the other one. So if we could actually look at this op amp, it's very difficult here to actually get it into place. If we go between these two last pins, there is our low impedance. So it's actually, the failure was in the op amp. So there you have it. The transistors appear to check with its adjacent channel, so no other problem seems to be present. We'll go ahead here and take our solder wick here and kind of remove this previous repair here that someone has done here with this through hole component, and we'll be replacing this through hole component here is a resistor someone has heat shrinked in. Appears to be the correct value. I guess there's probably really nothing wrong with that technically, but it's just the stress of the actual little pads cannot really support that kind of weight that might offer hanging devices out there. So I like to try to just go ahead and clean the pads. Someone left part of the old resistor on here. I like to just kind of clean up the pads if possible here, hoping someone hasn't really damaged the pads, because then we would have to just kind of use bus wire to kind of pad it back together. There's part of the old resistor flaking away there that was actually burned. Want to actually check this lead and so forth on this capacitor that someone has replaced, so I'll probably go ahead here and remove the solder around that capacitor and remove that component and kind of clean it up, kind of do it a little better connection than what they have here, because it's kind of, it works, but it's just kind of not, you know, to my standards. I like to kind of make it a little neater. So we'll turn that over, this being the capacitor that someone has replaced. And of course I will have to get probably a pair of tweezers to lift this out of here. Maybe I may be able to just lift it out, but they've put it on its side here actually because it's a little larger component. Can't really tell, but it looks like the top of that capacitor may be just slightly swollen. So I may want to actually look at the other capacitors and see if we have a, looks like they are at 25 volt, and this one is a 25 volt. So, you know, maybe this suffered from a surge or whatever that give us a little over voltage. But anyhow, both channels appear to be the same failure. Same parts were replaced. Evidently the op amp must have checked good at the time of the repair that someone had conducted on this thing. But anyhow, we'll be putting back a nice capacitor here, and it's sizable. If not, we'll have to lay it down on the other side. We'll just kind of verify, you know, we'll get the right 10 ohm resistors here, surface mount